Hello, so today we are going to solve problems from this week's contest. Count collisions of monkeys on a polygon. This is the second problem. And by the way, this is contest 330. Contest 330, okay? So what the problem says is we got a regular convex polygon with n vertices, right? So we have n vertices. And the vertices are labeled from 0 to n minus 1. Okay, so for example, here we have 6 vertices and are labeled from 0 to 5. Okay, and this labeling is done in a clockwise direction. So you can see this is the order we are doing here. And you can assume that on each vertex there is a monkey, right? So on each vertex we have some sort of monkey. And then each monkey moves simultaneously to a neighboring vertex. So they can move simultaneously to a neighboring vertex. So the one in 0 can move to 1, the one in 1 can move to 2. Or so either this would be clockwise direction, or they can move also in counterclockwise, right? So 0 can move to 5 as well. So they can move clockwise direction, counterclockwise direction, and the way you can calculate where they can move to is just plus 1 modulo n or minus 1 plus n modulo n. So this is to solve for, let's say 5, you want to move to 0. That's 5 plus 1, 6 modulo 6. So that would be 0. Now there is definition of a collision, where a collision happens if at least 2 monkeys are in the same vertex, right? So if, let's say, 0 moves to 1, and maybe 2 moves to 1 as well. Okay, so then there is a collision. Now the problem asks us to return the number of ways the monkeys can move so that there is at least one collision happens, only one collision happens. And we want to return it modulo this value in case it's too big. This is a very important note here, and that's that each monkey can move only once. So it's only one move. Okay, so let's see how we can solve this. So the idea here that the problem states the important piece, there are 2 important information. One is that each monkey can move only once. So it's only one move. And then the other information is that each monkey can do only 2 possible moves, right? Not the number, but only 2 options. You have only 2 options to move. You can either move counterclockwise or clockwise, right? So they can only like move from one vertex like this, counterclockwise, or they can move like this, clockwise. Okay, so only 2 possibilities here. Okay, so those are 2 important pieces. Now, what are we asked to do, right? That's important to also just highlight. So what we want to do is count number of ways, right? With these configurations, monkeys can move to have at least one collision. To have at least one collision. And the definition of collision is just that 2 monkeys are in the same spot, right? Okay, so this is a useful way of solving problems. Is if it's tricky to find the exact thing, think about how can you find it by subtracting 2 other things in the same space. What do I mean? Let's say you have, I don't know, maybe a pizza or a pie or something, and you are told that there are 3 slices that gone bad, right? 3 slices. How do you find the number of good slices? Well, you just need to find total number of slices, right? And then you need to subtract the bad slices, right? So let's say we are told there are 12 total slices. We just subtract 3 and we get that there are 9 good slices. Okay, so that's the concept that we will use here, which is like pretty self-evident. So that's what we'll use. And so here, what would that be for this case? Well, we can just find the total number of ways possible to move, right? And then what we need to subtract? Well, here we have only one move. So it's only possible to have either one collision or no collision, right? You can't have 2 collisions because for that you need the monkeys to move twice, right? And so this means that here moves with no collision. Okay, because with one move, it's only possible to have either one collision or no collision. And so those are the only two possibilities. So we take the total. So this would be the total number of slices. This would be, let's say, the bad slices, and this is the good slices that we want, right? So we just subtract. And so the problem becomes, how do we find these two? Are these two actually easier to find than the one we are looking for? And the answer is yes. Why? Because let's focus first on this one, the total number of ways. So for this one, we know each monkey has only two possibilities to move, right? So they can only move this way or this way. So that tells you for each monkey, we have only two choices. Okay? And we have n monkeys. So by definition, this means basically that we have two possible n moves, or two possible n ways to move, right? Because each monkey moves twice, have two choices, and we have n monkeys, right? So we already know that for this one here, it's going to be 2 to the power of n. Now, what about the moves with no collisions? Let's think about this. So for moves with no collisions, well, you could either, for a collision to not happen, one possibility is that each monkey moves to the next vertex. So 0 moves to 1, and because 1 moved to 2, there is no collision at 1. But then 2 needs to move to 3, so that there is no collision at 2. And then 3 moves to 4, and then 4 moves to 5, and then 5 moves to 0. So we end up with something like, basically if each monkey moves to the next vertex in a clockwise direction. So we would end up with 5 here, 4 here, 3 here, 2 here, 1 here, 0 here. Okay, so that's one possibility. Now, is there another possibility? Well, they can do the same except counterclockwise, right? So how will that happen? So they can do like this: 0 moves to 5, and to not have a collision, 5 moves to 4, 4 moves to 3, 3 moves to 2, 2 moves to 1, and since 0 is free because 0 moves to 5, 1 can move to 0, and we'll end up with a configuration like 0 here, 5 here, 4 here, 3 here, 2 here, 1, 0, 1 here. Yep. So we'll end up with this configuration, and with this there is no collision. You can see two monkeys are in the same place, and each of them moved only once, right? So we have the two conditions valid. So we have another way here. Now, can you think of any other way to not have a collision with one move? Well, it's not possible, right? If any of these monkeys doesn't move to the next vertex, we will have a collision, right? So these are the only two possibilities, is exactly 2. So that means the possibilities without a collision are 2, and so this is basically our result. This is what we want to return, right? So very straightforward, actually. Now, we just need to be careful here because n can be pretty large. It can be up to 10 to the power of 9. And so we need to do this power in a nice way. In Python and in some other languages, you can just use this power function, 2 to the power of n, and pass in the mod so that the power function will use it. You can also think about doing it like custom in your own implementation, but it's a little bit cumbersome, so I won't do it here, but yeah, feel free to try that. Yeah, so let's implement this and make sure it passes. Okay, so let's implement what we saw in the overview. So first, we definitely need to define the mod function, the mod value, right, that we get, which is 10 to the power of 9 plus 7. And then we just do the exact formula that we saw, which is 2 to the power of n plus minus 2, right? So that's in Python, you could do 2 to the power of n and then pass in the mod and minus 2. And then we just need to mod the entire thing, right? Just in case. So this would be pow, and then we do modulo mod, okay? And that should be it. So if we run this, looks good. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.